This video demonstrates how Hopr's workload security proxy, nicknamed WoSP, connects host workloads operating in any environment and secures their data communications using quantum-proof, end-to-end encryption without exchanging the key. The video also demonstrates how host workloads are protected from untrusted workload connections. Here we have a communication between two cloud endpoints. At the top, we have the Babar endpoint, and it's communicating across the internet with the Cornelius endpoint shown at the bottom. And you can see that Babar is getting a response from its messages to Cornelius. Every 30 seconds, the Babar endpoint is starting a new session with Cornelius via a Hopr WASP, and Cornelius is using its WASP to separately start a session with Babar. And all of this communication is happening over the internet with bidirectional end-to-end encryption through the two WASPs using Hopr's synchronous ephemeral encryption protocol. And you can see the actual curl command from Babar to Cornelius, and vice versa, is not encrypted. You can see here that our endpoint is connecting to an unencrypted HTTP web server. There is no TLS, nor any other external service involved in encrypting the messages. Quantum-proof symmetric keys are generated in the WASP and remain there to encrypt or decrypt messages between the two workloads. The data they exchange is protected over the entire route between them. But if a third endpoint appears and tries to connect to Babar, you can see that a response is not returned. The third endpoint's message to Babar is initiated and travels over the internet into the WASP at Babar, but it fails decryption and is black-holed by the WASP. The message is not seen by Babar, and no response is returned to the sender. This is very useful for application endpoints on the internet, because any type of response, even rejection, can positively identify the existence of an application. So the WASP drops all untrusted and potentially malicious ingress messages, including any that may contain TLS encrypted malware. But if this third endpoint was a trusted endpoint, all the third endpoint would need to do is activate its Hopr WASP configured with the correct CHIPS algorithm. Although the third endpoint cannot access the Babar endpoint directly, when its message to Babar is sent through its WASP, you can see that we have accessed the WASP listener port on localhost, and the message is decrypted by the WASP at the Babar endpoint. The symmetric encryption occurred on demand without a key exchange or handshake, and it's continuous between the third endpoint and the Babar endpoint. Every single communication session that is initiated by a WASP will generate a new key based upon a specific CHIPS algorithm and unpredictable dynamic internet information. This produces unique keys for sessions between a single pair of networked application workloads, but also for sessions with any other networked workloads or networked apps that are micro-segmented by using segment-specific CHIPS algorithms. Hopr WASPs enable high-trust, ultra-secure, quantum-proof application networking across all environments. You can learn more at hopr.co.